Bismillahirrahmanirrahim. Welcome to another experiment of modern physics. This is a photoelectric effect, a very simple experiment, and we use this photoelectric effect to determine the Planck's constant H, whose values is 6.625 10 raised to power minus 34 joule second. You have gone through the black body radiation. Planck's ने जब solved this maze that black body radiation man gave a famous formula where there was a constant H which had a very small value. Einstein used it, and Einstein said the energy, photon energy, is quantized and is given by E is equal to h nu. So if we know the frequency, we can find out the energy by multiplying it with this Planck's constant. Now he used this formula to explain the photoelectric effect. That was a puzzle at that time because the classical physics failed to explain the photoelectric effect. Now what happens in photoelectric effect? We have a metal surface, एक metal surface है, उसमें से जब photon of some defined frequency falls on that one, तो उससे इलेक्ट्रॉन सरफेस से इलेक्ट्रॉन्स एमिट होते हैं जिसको हम फोटो इलेक्ट्रॉन कहते हैं इन इलेक्ट्रॉन्स को. सो दिस फोटो इलेक्ट्रिक इफेक्ट वाज नॉट एक्सप्लेन्ड यूजिंग द क्लासिकल थ्योरी, जो कि एक्सप्लेन करती, जो बताती थी कि जो फोटो इलेक्ट्रिक इफेक्ट है ये इंटेंसिटी के साथ रिलेटेड है, बट आइंस्टाइन एक्सप्लेन्ड इट इज़ नॉट रिलेटेड टू द इंटेंसिटी ऑफ द लाइट, बट इट इज़ रिलेटेड टू द फ्रीक्वेंसी ऑफ द लाइट और द एनर्जी ऑफ द लाइट. नाउ व्हाट हैपन्स, I've got a band diagram over here of a metal. We have a conduction band. This is the highest level filled by the electrons. हम इसको Fermi energy कहते हैं. And then this is the vacuum level. So this is the energy barrier which is needed for this electron to get out of the metal surface. उसका आम नाम है work function. So that is the work function. So we have a photon of energy h nu with the frequency nu strikes the metal surface. It can excite an electron from the top of the Fermi level to the vacuum. So it can go up and it can cross this barrier, provided this energy is greater than this work function and or equal to this work function. So what happens if it is equal? So it goes right at the top of right at the lowest level over here, but if it is greater than work function, the remaining energy is converted into kinetic energy of this photoelectron. Now there are four postulates regarding the photoelectric effect. Number one, no photoelectrons are emitted if the energy of the striking photon is less than the work function. Number two, the photoelectrons are emitted only when this energy or the frequency is above the some threshold frequency, and that threshold frequency is defined by the work function of the metal. So if the photon energy is equal to the work function, then the extra energy which is taken by the electron is zero, but if it is greater than the work function, the extra energy is converted into to the kinetic energy of the electron. This is what we are going to do in this experiment. इस experiment में यही होता है कि हम stopping potential जो measure करते हैं वो actually this excess kinetic energy जो उनको जा रही है उसको हम measure करते हैं. And then number 3, the number of photoelectrons increases with the intensity. Okay, so once we have hit the threshold frequency, we can increase the number of electrons by shining more light over there. But if the frequency is less than the threshold frequency, no matter how much light intensity we shine, there will be no photoelectron. And the fourth one is the photoelectric effect is an instantaneous. So as soon as light hits the metal surface and its frequency is greater than this threshold frequency, then the photoelectric effect will happen. If it is less than this threshold frequency, then there will be no photoelectric effect. So I leave this part now with you need to think what phenomena can take place when light hits a metal surface. So we have studied कि एक तो हो गया फोटो इलेक्ट्रॉन जनरेट हो सकते हैं. बट व्हाट हैपन्स इफ देयर आर नो फोटो इलेक्ट्रॉन्स जनरेटेड? क्या फोटॉन्स उस मेटल पे कोई काम नहीं करेंगे? इज देयर नो अदर मैकेनिज्म ऑफ एनर्जी ट्रांसफ़र? व्हाट आर द अदर मैकेनिज्म्स ऑफ एनर्जी ट्रांसफर्स? ये बहुत इंपॉर्टेंट है, ठीक है. इस यू नीड टू स्टडी नो दैट वन एज वेल. There is not only one way of absorption of this photon by producing photoelectron, but there are other ways of absorbing these photons. I can give you a clue. जितने हमारे antennas हैं ना, transmitters और receivers, they are based on these electrons which are at the surface of metal and they are participating into it. हम मोबाइल फ़ोन लेके फिरते हैं ना, इसके अंदर metal के antennas लगे हुए हैं, and these use these surface electrons. अब हम what we do is I'll write down the equation और उस equation को explain करते हैं. Now quickly we have E is equal to h nu, which is the photon energy, and I can write down the kinetic energy of the electrons is h nu minus w. In our experiment, we find out the h nu by EVS, which is Vs is the stopping potential, ये आपने इलेक्ट्रॉन डायफ्रैक्शन में देखा होगा कि काइनेटिक एनर्जी इज रिलेटेड टू द अप्लाइड फील्ड जो फ्री इलेक्ट्रॉन का है, इज इक्वल टू एच न्यू माइनस डब्ल्यू. आई कैन राइट डाउन वी एस इज इक्वल टू एच ओवर ई न्यू माइनस डब्ल्यू ओवर ई. तो अब आप देखें, दिस इज इक्वेशन ऑफ अ स्ट्रेट लाइन. ये स्ट्रेट लाइन की इक्वेशन है. तो इसमें अगर आई प्लॉट y-axis पे I put Vs and on x-axis I have frequency. So I will get a line, straight line, which will cut through, और y-axis पे वो cut करेगी because of this minus W. That will give me the work potential, and the slope of this line is h over E is the slope. This is what you have to do. हम experiment करेंगे. We will take 3 or 4 wavelengths. We'll find out their corresponding potential. They will, all these points has to lie on a straight line. तो straight line में fall करेंगे, उसकी slope निकालेंगे, and slope is equal to h over e. तो यहाँ से आप Planck's constant निकालेंगे. So यहाँ से Planck's constant. So in our experiment, what we have done for you, हमने wavelength नहीं define की. We used the filter. We took the spectra of the filter, and we want you to determine the wavelength from the spectra. Very simple. आप ग्राफ देखेंगे आपको फ़ौरन पता चल जाएगा. और प्रिसाइज लेना है तो you do a fitting, Gaussian या Lorentzian fitting करें, आपको wavelength पता चल जाएगी. We have measured the stopping potential. तो आप उसको plot करें, you will get that one. But we will ask you to do one more thing which we have done. अगर आप band diagram देखें, वो ये है. So this is Fermi energy. So all these are field levels, and the electron goes from here to there. Okay, so this is W यहाँ तक, और ये this part is the kinetic energy, and this part we have photon striking it. If I look at this equation, if this one is greater than this work function, so I will have higher kinetic energy over there. So there is a relation of wavelength. So जैसे जैसे frequency बढ़ती जा रही है ये इलेक्ट्रॉन ज़्यादा ऊपर जा रहे हैं. So higher the frequency, the larger the kinetic energy. So this means that in our experiment they will take different time to reach to this stopping potential. So I would suggest हम वहाँ पे stopwatch रखेंगे. Find out the time. Is it the same for all wavelengths or different? और अगर ये different है तो what is the reason for this difference? तो ये experiment करना है आपने. There's a lot of learning. We have tried कि आप ज़्यादा analysis करें data का. You are free to come and do this experiment by yourself. Good luck.